Good afternoon, friends. So today we are going to study the next chapter, that is unit number 5, design of compression molds. Design of compression molds. Now in unit number 4 we have studied the design procedure for plastic part. Here there will be design procedure for compression mold. Now what are the contents of this chapter? The contents of this chapter are design of various the parameters of various compression molds, which includes the bulk factor, then ejector pins, then loading chamber, and then land dimensions, etc., etc. It also includes some of the critical concepts or important concepts such as heating of mold. It also includes how vents are provided. Then after or end part of this chapter includes this transfer mold. So technology used for transfer mold and different parts and automation in transfer mold, because transfer mold works on the principle of compression mold itself. So there is no separate design for transfer mold. We are going to see the design procedure steps for compression mold design. So outcome of this chapter, at the end of this chapter, students will be able to design a compression mold for a given component. Means some figure will be given to you. If you are the design engineer, some customer will come to you and customer will give some drawing and some material may be decided for making that component. Then as a design engineer or as a manufacturer, you have to make the mold for that component. Suppose the order is of 10,000 components. So that 10,000 components are prepared in one mold. Customer is not having any mold. Customer only wants that component. So as a manufacturer, as a design engineer, you have to make the mold, and then in that mold you have to make the 10,000 components. So what are the different steps in designing that particular compression mold? Okay, so the outcome of this chapter is, at the end of this chapter, students will be able to design a compression mold for given component. So remember always that. And one more thing, so we have only the illustrative type design steps. So we are not going to consider the cooling and other things, etc., which are very complicated. So simple steps of the design are considered, and we will see 2, 3 or 1 or 2 cases or illustrations for design purpose. If exam is subjective, this design procedure is asked in the examination for 6 marks. Some drawing will be given to you and it is asked to design the compression mold. Okay, so these are as far as contents of the compression mold, design of compression mold chapter. This unit is 5th unit. We have total 8 units. Okay, and as far as ISC is concerned, your ISC may be coming after few days, and you can consider that syllabus for ISC may be up to first 4 chapters. So the first important bit from this chapter is mold heating. What is this concept, mold heating? So recall your memories. We have studied the chapter number 2. So various plastic making processes or processes on the plastic. What was explained there? It was clearly explained during that chapter that when you are going to make the component with the help of compression molding, the loose plastic granules are kept in the mold. Mold is heated. Then heat of mold will cause that plasticize the component. Heat of mold will cause that plastic to reach into plasticize the stage, semi-solid stage, and then you are going to press it from the upper side and then it will flow into the gap between punch and die. So here, heating of mold is important. How molds are heated? So your ready-made setup is already there, and then which mean is used, or what is the medium for heating is used. Usually molds are heated with the help of steam or oil. How to heat by steam or oil? So steam means hot. Steam is produced from water. Steam itself is hot. So either steam or hot oil is circulated in the gap or channels of the mold. So these channels are provided, and then after circulating it, mold will be heated. So what temperature is required for heating of the mold? So XY temperature is required. That temperature is maintained. How to check whether temperature is correct or wrong? Then some thermocouples are fitted in the mold. Now by circulating oil or by circulating the steam, the molds are heated. Sometimes instead of oil heating or steam heating, the electric cartridge heaters are also provided. So ready-made some circular wire circulating the coils around the mold, which are controlled by just on-off button. So you can start heating. But what happens when electric cartridge heaters are used? Problem in this on-off problem, and there is problem of maintaining the uniform temperature. Hence, the preferably oil or steam may be sometimes be heated, because oil steam also have some disadvantage. Electric cartridge heaters may also have some disadvantage. So optimum solution is find out, and then mold will be heated. So heating of the mold is one of the important steps in compression molding. You can just write down 3-4 lines. I will dictate to you. The optimum mold temperature is when each half of the mold is at a difference of 3 degrees Celsius. Means if this is your mold, this is first half, this is second half. So you are going to check the temperatures. You should find a difference of 3 degrees. So that is permitted. Tolerance is given. Tolerance. Just 1 minute. So just I will say tolerance of 3 degrees Celsius. If it is there, we can say that our condition is good. So if you find more difference between this point temperature and this point temperature, then you can say that some optimum temperature to be maintained, because uneven heating of the mold will cause deteriorating the properties of the product which are produced through you by using that mold. So mold heating is important step here. Difference of 3 degrees you have written. In case of the heating is carried out by oil or steam circulation. Heating is carried out by oil or steam circulation. Sometimes electric cartridge heaters are also used. electric cartridge heaters are also used. And now next line, important. When the mold temperature is uniform, the properties of the components are better. When the mold temperature is uniform, the properties of components are better. Full stop. It is more difficult to maintain uniform temperature with electric cartridge heater. It is more difficult to maintain uniform temperature. It is more difficult to maintain uniform temperature. It is more difficult to maintain uniform temperature by electric cartridge heater. Full stop. Steam heating is most efficient. Full stop. So next important thing, the distance. See what I have told. Heating temperature here, here, here. How to measure that temperature? How you know that? Suppose mold temperature is 100 degrees Celsius. At one point 103. Another point it is 97 degrees Celsius. How to measure it? Thermocouples are used. So how thermocouples are located? So there is a proper justice to the location of thermocouple which heater is given. See how I am drawing the figure. Just wait. This is thermocouple and these are the heaters. This is your product. Draw this figure. Here, what is shown? This is upper half, this is lower half. So this is the core part. This is your product. Now, near to this product, thermocouple is set. This is cross section, and these are the heaters. Heaters are here also. Okay. What is given or what is the requirement as per the standard? As per the standard requirement, the distance between thermocouple and heater be maintained 1.25 inch to 1.5 inch. I repeat once again. So this distance may also be same. This distance may also be same. 1.25 inch to 1.5 inch. What will happen if this distance will not be maintained? So too close heater will cause thermocouple on off. If this heater is very close to that thermocouple, so that thermocouple on off problem will be there. That's why sufficient distance must be maintained. Heater will hit the mold and then thermocouple will sense that temperature. But if thermocouple itself is very close to heater, it will cause the problem. And if thermocouple is far away from the heater, then also the core heating problem will be observed. You can write the statement. There is proper distance maintained. I hope you have drawn this figure. Mold heating. There is proper distance maintenance or distance between. Sorry, repeating that. I will repeat. Correct the sentence. The distance between thermocouple and heaters. The distance between thermocouples and heaters are maintained so as to achieve desired procedure. If the distance is too close, TOO, if the distance is too close, it will cause on-off problem of thermocouple. Distance is too close, it will cause on-off problem of thermocouple. And if distance is too far, TOO, if distance is too far, it will cause problem of core heating. Because what will happen if thermocouple is at far distance, so it requires more time to sense that temperature, and here there will be expanding of the cores, etc. Core means this extended part is called as core. Hence, the optimum distance we maintained, which is as shown in figures. Hence, the optimum distance we maintain, which is as shown in figure. Then next small bit is venting. Hello. Sorry, there was a little disturbance. So we are talking about the vent. So what is vent? Everybody knows what is meaning of vent. So vent is nothing but that gap or that port through which the hot gases or steam will go out. Hot gases or steam will go out. Means what? You are going to do the molding process here, friends. So plasticized plastic is compressed between two halves, upper half and lower half. In that case, whatever gases are generated, these gases produced by plasticizing the plastic material, whatever gases are produced, these gases must be escaped through this mold. Otherwise, these gases will become part of that product. And if these gases are trapped in between the product, you will find the shrinkage, cavities, and other defects. Hence, so it is compulsory that when the mold is metallic, you are going to provide the vents by providing the drills in the mold. In the chapter of this gravity die casting in manufacturing process subject, you know that as far as mold made by sand are concerned, there is a concept of permeability. So permeability means the ace with which steam or hot gases leaves the mold. Now there is no question of permeability in case of metallic mold. There is no question of permeability in metallic mold. So then what can be done? You have to create the artificial holes which must open in the mold and lead to atmosphere. So these holes which are created in the metallic mold for escape of the gases, hot gases and steam, are called as vents. Now here some mechanism is used so that you can get the good venting effect. Venting means opening the mold to the atmosphere through the small gap. Now you know that in this any type of molding, so here we are studying now compression molding. So compression molded product after solidification will be ejected out by ejector pins. Ejector pins means the pins which are coming out by pressing the lever. Once the pins are coming out through the backside of the mold, these pins will force that plastic product, solid plastic product outside the mold, and it will fall in the bin. So pins are moving in the hole and there is a gap. So usually vents are provided in the gap of ejector pins in this case. See, and if vents will not be open to atmosphere, it is of useless. All vents must open to atmosphere, otherwise it is useless. And these vents are provided at the gap of ejector pins. Now, one important thing, unless the part of geometry shows some obvious location for vents, brief molding trial will be conducted. Brief molding trial will be conducted to observe the gas voids. Voids, VOIDS. Voids means your gap or cavities, your bubbles, blow these pinholes and other holes which are produced in the casting. So these gas voids may be produced in the plastic component, and hence some molding trials are required whether the vent which is provided is really opening or not. Means that must be open to atmosphere. It must not be blocked by some dirt particles or other plastic or solid, unsolid or solidified plastic. So whenever possible, the vent should be located in the movable half. Movable half, there are two halves. One is fixed hub, another is movable hub. So vent must be provided in the movable hub of the mold, and neat line on the part. KNIT, neat line means usually you are observed. So where the locator pin is touching to the component. Okay, and most important thing here, see, your ejector pins are moving through that hole, so it must not be jammed, it must not be tightly fitted. There is easy motion, and hence the depth of vent is important concept. Actually, that word depth here is nothing but, when I will draw the figure, you will understand. When I'm using the word depth of vent, it is not actually the depth, it is the gap between ejector pin and wall of the hole. So the depth of vent will be shown here, and it is always recommended that all vents are drawn polished. There must be very fine and very good quality of polishing, so that ejector pins will also move without any resistance, and there will be proper opening of the mold to the atmosphere, and finishing of the vent is important, and that must be in the direction of flow, and vent should be polished for their entire length including relief distance. So length of the vent, how to measure the length of the vent? Vent must be polished throughout its entire length. How to measure the length of vent? So starting from mold wall up to the outside face of the mold, that is called as length of vent. So depth of vent and length of vent, what is that? That I will show in the figure now. You just see. Just see the depth of vent and length of vent. So there is a minimum to maximum. So minimum gap may be 0.254 to maximum depth may be 0.013. Okay, just check. Minimum clearance around the ejector pin, that must be provided, otherwise there may be problem of jamming the ejector pin. Minimum clearance. This is the length of vent. Minimum clearance around ejector pin, and it is 0.254 mm, and vent depth is here. Draw this figure. Sorry. I hope I'm audible to you. So this is ejector pin. So I repeat the statement once again. The purpose of ejector pin is to remove the solidified part from the mold. Along with it, it helps in providing the vents. It also helps in providing the vents because vents are provided around the ejector pin. Now, ejector pins are of different type. What is its what must be its location? How many ejector pins may be provided? And then what may be the design? That concept is totally different. I hope you have drawn this figure. So this remaining part we'll take in next time. This about ejector pin, etc. Here, I want to concentrate the thing. Whenever compression mold is designed, in that compression mold, the upper half, lower half. So these two halves are heated with the help of some means like steam or oil. The efficient heating usually is given by the steam. Oil is half of the efficient than that of steam. If you use this oil or steam, you may achieve the heating temp or mold heating temperature with tolerance of 3 degrees. Means randomly if you measure temperature at 2 points, you will not find difference more than 3 degrees. Then you can say that you have achieved the good and uniform heating of the mold. Second thing which we have studied, which I have explained, is the source of heating is electric cartridge heater, but their tolerance of heating is not achieved, and that's why it is observed that steam be considered as a most efficient heating media for the molds. Compression molding is usually used for thermoset plastics. Okay. Now, once when you are going to heating or when you are going to heat that plastic component, whatever steam gases are produced, they must be relieved outside, and for that purpose, vents are provided. So, location of vent, depth of vent, minimum clearance between this ejector pin and the gap or hole, all these things are covered in the unit venting. This may be asked for 2 or 3 marks in the short note in case of subjective questions. In case of objective questions, you have to remember this: what should be the minimum gap, what will be the vent depth. See now that for gap, word depth is used. Meaning of depth of vent is gap between the inner surface of hole and ejector pin. That is called as depth of the vent. And length of the vent is starting from what? Suppose ejector pin starts from here and open here. Actually, this leads to mold directly. Here your component is below it. Okay. So length of vent I am talking. Length of vent starts from mold opening to the atmosphere. So here your mold wall ends. Where your mold wall ends, or that is outside surface of the mold, that is directly opening to atmosphere. So that is treated as length of the vent. So you should remember this as far as MCQ are concerned. Then you must remember what should be the minimum distance between thermocouple and heater. So optimum distance maintained between thermocouple and heater is 1.25 inch to 1.5 inch. If that distance is less, cyclic on-off of the thermocouple will be observed. If that distance is more, you will find core heating, because your thermocouple will not sense the temperature when it is far away, and by the time overheating may be possible, and hence the minimum distance or optimum distance range from 1.25 inch to 1.5 inch. This is all about the important bits of the compression mold. Just wait. So, okay, friends. So this is all about the today's bit which we have covered, and from the next class we are going to start, or whatever the next lecture, we will start with the ejector pin location and design of ejector pin. Actually, meaning of word design means just we are going to see the guidelines for using the ejector pin in the compression mold, and how the end of pins are to be provided, how it is located, etc., will be covered. Okay, we will stop here. Thank you.